strong float, I think. You can set it over there probably. All right, got your title if you want that? And iPads flipped over. iPads flipped over. Okay, showing lines are parallel is our lesson for today. Today's lesson involves what are called converses. And that's what we'll first talk about, and then we'll look at what the converses of yesterday's lessons are. That we done? All right, a converse. Converse is a statement that is formed by switching the hypothesis and conclusion of an if-then statement. Switching the hypothesis and conclusion of an if-then. Formed by switching the hypothesis and conclusion. And then I put an example up here for us to look at. The statement, if you live in Sacramento, then you live in California. Okay, before I look at the converse, let's review the ideas. What's the hypothesis and conclusion of this statement? Hypothesis is what? Austin Forney? On this statement, which part's the hypothesis? I know some of you are still writing. But which part's the hypothesis? Nope, that's the conclusion. Okay, so you live in Sacramento is the hypothesis here. And then in green, you live in California is the conclusion. So now today we're going to talk about a converse, and the converse takes that original statement and switches the hypothesis and conclusion. So now notice that you live in California is the hypothesis. And then you live in Sacramento is the conclusion. So it's switched from the statement to the converse. Now, do they say the same thing? Let's think whether they're true or false. Okay. If you live in Sacramento, then you live in California. I know there's a Sacramento, California. Anyone know of a Sacramento in another state? I don't think there's a Sacramento in Nebraska. And I guess just our knowledge maybe isn't enough, but as far as we know,
I was testing you.
as far as we know, if you live in Sacramento, then you live in California would be a true statement, because we can't think of any other Sacramento besides California. If we reverse it, the converse, if you live in California, then you live in Sacramento. Not true? Why not, Austin?
Because we don't know if
Los Angeles.
Okay, there are a lot more places in California that you could live besides Sacramento.
And also there could be a Sacramento in a different state.
Okay, if there is a Sacramento in a different state, that would be a counter example to the original one,
Oh, okay.
not to the bottom one. The bottom one would be a place in California, but not Sacramento,
Okay.
like Los Angeles, San Diego. You can probably think of quite a few there. Okay, so I tried to set it up so that you notice that the statement was true. If you live in Sacramento, then you live in California, but the converse was not true. If you live in California, then you live in Sacramento. So just by switching the hypothesis and conclusion, you might create a statement that is not true even if the original one was. Sometimes it goes both ways. For instance, I guess a definition that we have. If a point is a midpoint, then it divides a segment into two congruent segments. If we reverse that as the converse, if a segment is divided into two congruent segments, then it has a midpoint. converse that, it should sound like it's true both ways. So converses could be true, they could be false, it depends upon the statement. Okay, so I'm giving you a statement here, and instead of you writing it down, we'll actually just raise our hands. But if it is Western Day, then Mrs. Frank wears boots.
Do you have boots?
Snow boots, not cowboy boots. My husband does, so I would probably wear his. Okay, so if it's Western Day, then Mrs. Frank wears boots. What I want you to do is write the converse, or tell me what the converse is. Don't shout it out, let everybody think. What would be the converse, and then we're gonna decide whether they're true or false. So first, what would the converse be? Switch the hypothesis and conclusion of this statement. Dustin, what would that sound like? Correct. So then, is that converse, I guess we'll give examples here, is that converse true? I guess you'd have to ask me, if Mrs. Frank wears boots, then it is Western Day.
I'd like to say no, because you can wear them on any day, pretty much that you want it. It doesn't just have to be Western. Because Tristan wears them every day.
So that would be a false, that would be a false converse. Okay. All right, next one, more math related. If angle 1 and angle 2 are right angles, then angle 1 is congruent to angle 2. First, think what would the converse be? Holden Hartman, what's the converse? Switch the hypothesis and conclusion.
If angle 1's congruent to angle 2, then they're right angles.
Okay? Now think about that statement. If angle 1's congruent to angle 2, then angle 1 and 2 are right angles. Is that a true statement? Two angles are congruent, then they're right angles. Mitch, what do you think, true or false?
Well, we don't know what the exact measurements are.
Want to explain a little bit more, Tristan? What do you mean?
You know what the exact measurements are, because it's not 90 degrees, right angles.
I know, I missed.
Well, are they right angles?
They don't
Now,
have to.
okay, what we're thinking of is
It would
here's,
be 108 degrees.
okay, here's the statement we're thinking of. If angle 1's congruent to angle 2, then angle 1 and angle 2 are right angles. Okay, so this is what we start with. What does that mean? Congruent, which means
Same.
same. Okay, if one's 10 degrees, the other one's 10 degrees. If one's 40 degrees, the other one's 40 degrees. If one's 82 degrees, the other's 82 degrees. If one's 90 degrees,
90
the other's
degrees.
90 degrees.
I'm not-
So-
it's 90.
So this means they could be anything, but they're the same. Okay? So let's say my first example, angle 1 is 10 degrees, angle 2 is 10 degrees. Those are two angles that are congruent, right? Okay? The conclusion, then angle 1 and 2 are right angles. No, I've got a counterexample right now. Remember doing counterexamples? An example that demonstrates a conclusion is false. Okay? So this statement is false because you can have congruent angles, they don't have to be right angles. Could they be? Yes, but we have a lot more situations where they're not. So yes, you were right to start with, you just got goofed up on your explanation. Okay, and bottom one, again, we're doing the converse and then trying to figure out if that converse is true or false. Okay, what's the converse sound like? Okay? Converse. Take the hypothesis part and the conclusion part and switch them. If M what? Measure of angle 3. Then okay, she did the right thing as far as coming up with the converse. Now let's figure out if that's true or false. So look and see what it says. It says angle 3 and 4 have to add up to 90.
It's true.
So think of any two angles that add up to 90. Is it true that 3 and 4 are complementary? Jamie, what's complementary mean? Complementary doesn't mean the same. Congruent means the same. Okay, two angles that add up to 90 degrees is what complementary meant. So, yeah, this one's true. If they add up to 90, they're called complements. If they're called complements, they add up to 90. That one, both ways, is a true statement. Why is that one true both ways? It actually is the definition of complementary angles. Definitions are true when you go both ways. All right, converses, switching the if and the then part, okay? All right, let's explore the converse ideas from the theorems we did on Friday. Okay, on Friday we had not measure a lot, you'll use a lot of the numbers in the diagrams. Okay, so we do have 4 converses, and they are the converses of what we did on Friday. So I know I gave you a sheet with the notes on Friday, but you've got time to write them down yourself today. Postulate 9 is the corresponding angle converse postulate. So if I gave you that picture, the hypothesis says we need corresponding angles congruent. That would be like angle 2 congruent to angle 6 would be corresponding. So if angle 2 is congruent to angle 6, then, read the then part of what you just wrote down. How would that relate to the picture? What are the 2 lines that are parallel? Mitch? Find the line names. Okay, so then P is parallel to Q. Notice I don't have parallel marked on the diagram because that's not what you start with.
We should draw the diagram.
Yeah, I think drawing the diagram and then when you put your if and then, it would make sense. And maybe you don't want to mark those angles because the next one, if you don't want to have to draw the picture again, just don't put the markings in there. But for this one on that diagram, if for instance angle 2 is congruent to angle 6, then today what we can conclude is those lines are parallel. A converse of the corresponding angle postulate. Next theorem? Not quite.
Wait, so don't put like the numbers in there?
Yeah, put the numbers in there, but a little bit ago I put 2 congruent to 6, which is good for this example. But if I don't want to have to draw that picture on every example, you probably don't want to mark those because it would cause you confusion for the next theorem. Am I ready now?
Not yet.
All right, the next one is the converse of the alternate interior angle theorem. So once you've got that picture drawn, you have a pair of alternate interior angles. 3 and 5, correct? So if angle 3 is congruent to angle 5, then what's the conclusion? Dylan?
P is parallel to Q.
P is parallel to Q. Two more.
Angle 4 is congruent to angle 6.
Yeah, if you would have angle 4 congruent to angle 6, then
P is parallel to
P is parallel to Q, correct. There would be another pair that we could use. I think I'll just put one up there for the example. Got it, Jamie?
How many more theorems do we have?
There would be 2 more theorems. Because which other ones would we have the converse of? The ones before this, alternate exterior. Corresponding we did before this
Yeah.
one. Okay, done? Okay, the converse of alternate exterior angle theorem. If 2 lines are cut by, yeah, you need to make sure you say converse. I don't think I circled that on the last one. Either by the number or, I don't learn them by number, mainly, or one reason is, I teach out of 2 textbooks, and the numbers are not the same in both textbooks, so it gets real confusing. Which one's on a different side of the transversal? Here's the transversal. 2 is on the top side of it. 8. Okay. So if we would make angle 2 congruent to angle 8, then what can we conclude? And P is parallel to Q. Those 3 pretty much sounded the same,
Yeah,
right?
they're all gonna be congruent, but the next one.
What's the next one gonna be?
It's gonna be supplementary,
Correct, and how do you know that?
because same side interior angles, supplementary.
Correct. Are we done with this screen?
No,
No?
I was telling you.
Okay, I thought you were doing that because you were done.
Okay.
Right, but he is correct. This last one is a little bit different because the angles aren't congruent, they are supplementary when it's the same side interior angles. So we need to pick out a pair of same side interior angles from the picture. And we need to clarify or say that they're supplementary. That's what we would start with. Austin?
Number 4 plus, if the measure of angle 4 plus the measure of angle 5 equals 180 degrees, then line for P is parallel to Q.
Exactly. And there would be a different pair you could use, but he did 4 and 5. So if the measure of angle 4 plus the measure of angle 5 is 180 degrees, where do you get that from? That's what supplement means. They add up to 180. Then the lines P and Q are parallel. What would be the other pair he could have used?
3 and 6.
3 and 6. Okay, got all your long theorems? All right, let's see what other examples I have then. Okay, so can you conclude the lines are parallel? Why? Why are they parallel? They just seem, oh, that's not a good thing to say. Just seem.
Look how straight.
So you're saying I made a good picture? What would have to be true? I need to give you another angle measure. Based on what I got up there, you don't have enough information.
Yeah.
Now, if I put 120 degrees right here, are the lines parallel?
Yes.
Okay, support it. Why? What concludes that the lines are parallel? Look at your notes there, which thing? Now, what pair are they?
Corresponding.
They are corresponding angles.
P9.
They're in the matching positions, and I made them congruent. So this would be the corresponding angle converse postulate 9
Yeah,
to get the lines parallel. Okay? What if I put 120 degrees here? Are the lines parallel?
that'd be theorem 3.8.
Which was my title?
Interior converse theorem.
Okay, alternate interior angle converse theorem, yes, would give me the lines parallel. If I put 120 here, are the lines parallel?
Huh.
We don't know enough information, do we?
No.
You need to know something about this intersection. So vertical angles is not a theorem that gets lines parallel. I tried to trick you, but I didn't.
Yes.
Yes? By
Same side angles.
Measure of angle.
converse.
Measure of angle 120 plus measure of angle 60 equals 180.
And so that was the same side interior angle converse theorem. Okay, so you need to try and get the right words there. Okay, so on your either marker board, I think I decided on the marker board, if you would go to a program that could have a dark screen rather than a white screen, it probably is easier for me to see. So check your, if it's Edge Creations that you've been using, can you make a dark background?
Yeah.
45, and the one right beside it is 35 degrees. Can you conclude that the lines are parallel? Answer on your board for me. And if you weren't able to get a dark one, just use what you have available. And try and download something another time. Okay, can you conclude the lines are parallel? So first I need a yes or a no, I guess. That's all I need, is a yes or a no.
Yes.
Write it on your board. You could probably put like a one-page yes and one-page no, and then flip it to whichever one you want. Cool idea. Okay, show me your decided answer. Okay, I'm seeing some yeses and some nos, so we need to discuss this. Those that are saying yes, what's your support? Which converse theorem applies? And actually, that's where you're gonna get stuck. This is a linear pair. And there wasn't something that said if the linear pair is supplementary, then the lines are parallel. No. That should have been a no, because we don't know any angles at this intersection. If I would put 145 degrees right there, are the lines parallel? Show me. All right, this one should have been yes. Now, what's the support for this one?
Converse AIA.
Converse of alternate interior angle theorem, correct. Okay, how about that combination? Are the lines parallel? Showing me. Show me. Okay, it should be no.
Well,
If you said yes, I saw some of you putting same side interior angles, which I agree they are that. Are the same side interior angles supplementary up here? Do they add to 180 degrees? No. So that wasn't the right relationship. All right, how about this one being 87 degrees? Are the lines parallel? Are they? Okay, show me. This one should be yes because of the converse of the alternate exterior angle theorem. All right, now this one's a little bit different. It says find the value of x that would make the lines parallel. So what you need to do is figure out, do you need these two to be congruent.
Over
That's
here.
where I messed up.
So it should be +2 over here instead of right here.
Okay, answer should be
104.
104, because you needed them to add up to 180 degrees. So you could combine that and get 76, and then subtract the 76, x would be 104. They needed to be supplements. How about this one? Figure out the value of x to make the lines parallel. All right, what do we come up with?
85.
85 would be correct. It's not that they're supplementary, you're setting it up wrong.
They're congruent.
This one would be congruent, because the alternate interior angles have to be congruent in order to make the lines parallel. So you should have set them equal to each other. And when you subtract x was 30, or 85? For that one, okay? How many got that right?
I was right and didn't know
All right, and
I
I
feel
finished.
smart.
Okay, and find the value of x to make this pair of lines parallel. Should they be congruent? Should they be supplementary? See what pair they are. How did you set it up to it? Just guess. Should they be equal? Should they be supplements? Okay, how did you set it up, Mitch?
2x plus 10 equals 9.
Okay, so you're making them equal, and you ended up with x being 40?
Yep.
And how many did that one right?
2 hands up.
Okay, I think on the construction